Hello everyone, I'm Sigdha Kakkar and this is my channel AccelerateAICareers. Today, we are going to solve a very interesting LeetCode problem, LeetCode 80, remove duplicates from sorted array 2. It's first part we have solved already. It's a medium level problem, has been an online favorite for Amazon, Microsoft, Google and Meta. So now let's see what does this question say. So you have been given an integer array nums here. The array could be of something of this sort, like he given here 1, 1, 1, 2, 2, 2, 3, 3. And you have to remove the duplicates, some of the duplicates in place there. So basically you are allowed to have at most 2 copies of each unique element. Like you can have 2 1s, 2 2s and 2 3s, but no more than them. And you have to do this replacement in place. The arrays are non-decreasing basically, so they can be ascending or they can have duplicates like I mentioned here. And this in-place modification should take at max O1 of x for n. That's your question of condition. Now what should you return? You should return an integer k, which indicates the size of the new array. Basically, once you remove this 1 here, you have to shift this 2 here, then this 2 here. Similarly, remove the extra 2, then you move 3. So you have 1, 1, 2, 2, 3, 3. Because you're doing it in play. So you cannot just pop them out. You have to just replace it with the next element. And you have to bring all the other elements later on, like after your array is sorted. And you have to return that indices, that integer value k, which includes all the sorted arrays, and the next integer, the next indices is something which is your k, and you return that, showcasing that your first k slots of this nums array is the sorted version of this array. That is, it has at max 2 repetitions of each element. So when we solved the first part of this question earlier, which was remove duplicate from sorted array 1, at that time, we used a 2-pointer approach and initialized 2 pointers, left and right pointer, and spammed through the entire array and kept on removing the duplicates there. The question then required having only unique elements and no duplicates any further, so it was on the easier side of it. Now here, we can have duplicates, but at max 2 duplicates for each unique element. So the question complexity increased. Now, can we solve it using the 2-pointer approach as we used it earlier? Can we do it using the same approach? So let's try doing this example using that. So I start my left and right pointers and initialize them by 0. So my ith 0 element is 1. So right now I don't have any duplicates. I can increment both left and right pointers and come to index 1. Now my element is 1 again. Now I'll have 1 repeated twice here. So I can still have 2 duplicates, so that's okay. I can increment my left and right pointer. So instead of being at 0th place, now my left pointer is at second index and my right pointer will also be at second index. Now after that, on my second index I come across 1 again. So this is my third one. I've already come across 2 ones there. So I don't need this one. So I can strike it out. But what does striking out mean here? You cannot just pop up the element, right? If you have to pop up the element, you cannot do in-place replacement here. So to do the in-place modification of the array, you cannot pop out this element. Instead, you have to move the next element to this place. So for doing that, we keep our left pointer here. We do not increment it any further, but we increment our right pointer. And we come to the next element. Now my next element is a 2, which is not 1, right? Which is not a repetition of 1. So I can do the swap. I can bring 2 in place of this 1 here. That is, I'll copy a 2 here. And this would be my new modified array. Now after doing this modification, I can increment my left pointer as well. Now I check the next element is also a 2. And I can have 2 2s, right? So that's okay. I can increment my left pointer again. And I can increment my right pointer again. Now I've already incurred 2. So what does this left pointer actually indicate? This left pointer actually indicates that anything before that in the array is our answer, is part of our sorted answer. So you have 2 1s and 2 2s, which is the sorted max 2 duplicate condition, right? So it's satisfying that. Now you have come across the third 2. So what you're gonna do, you are gonna keep your left pointer here, because you have to replace this 2 with the next element, right? And you're going to increment your right pointer. So when you increment your right pointer, you bring it here. It's also a t. So what you're going to do, you still going to increment your right pointer again. Now you come across a 3. Now with this 3, you can replace this 2 where your left pointer is there. So here you can bring this 3. Now you can increment your left pointer. Now you have right pointer at 3, which you already checked. Now you can bring your right pointer here. So it's again a 3. You can do this 3 replacement with your left pointer. So instead of this 2, you can have a 3. And your right pointer has reached the end of it. So you basically looped with your left and right pointers through the entire array. And you will also increment your left pointer at the last. Because you have incremented your right pointer, you increment your left pointer. So before this left pointer, you see you have 2 1s, 2 2s, 2 3s, which is the requirement for your array, right? You can have maximum 2 of each unique element, all in sorted non-descending order, I would say. And then you have to return the index k, before which everything else is satisfying the question of condition, that is a sorted non-descending array. So do you see that that k value is none other than the left pointer? So you have to return the left pointer parallelly here. This is how we're going to solve this question. Now when we talk about time complexity and space complexity for this question, the time complexity here is O of 2n, because we will be using 2 nested for loops. So first loop will span across the entire array, and the second nested loop will check for the number of repetitions for each element that have occurred. And accordingly, the replacements will happen. Even though you're using a nested loop, it's not so bad, right? It's O of 2n, that is essentially O of n time complexity, which is linear type complexity. What about space complexity? Since you are doing the replacements in place, you're not popping out and adding the elements. So you're not using any additional memory. Your space complexity would be O of 1, as it has been mentioned as the requirement for your question here, O of 1 extra memory complexity. So now I hope the question and as well as the algorithm is clear to you. Now let's start coding it. Now we'll first initialize our left and right pointers with 0 indices. Once I have initialized my 2 pointers, I begin my first for loop, which will be while my r is less than length of nums array. That is, my r has looped around the entire array. That is my first loop. Then I'll also use a count variable to track the count of repetition for each variable. So I initialize my count as 1. Now I'll put my nested for loop condition where I will check my r plus 1 is also less than length of nums, just to ensure that it doesn't go out of bounds. It has not spanned the entire array and has gone out of bounds, just to keep tracking conditional loop. And then I check if there is any repetition. So if nums of r is equal to nums of r plus 1. If that is the scenario, I increment my right pointer and I increment my count to track the number of repetition. After this, I check for r in range and how many repetitions can it have, minimum of 2, and count. So the count would be greater than 2, right? But I can have maximum of 2 difference for each unique element. So that's why I've taken for I in range, min of 2, and count. There could be just one unique element and no repetition, and hence in that case the minimum would be a count, which is 1. If you have more than 2 repetitions and your count is greater than 2, in that case the min will lead to 2 value, because you can ensure you can have at max of 10 repetitions only. And then I will do the swap. So nums n is equal to nums of r, and then I'll increment my n after I return the swaps, and I'll increment my r outside the loop, because for this value, while r is less than length of nums, I'll have to keep on incrementing r every time while this while loop learns. That's what I have done here. And finally my answer, what would be my answer? It would be L. So my n is essentially that k value which is being talked about here. Now let's run it. So it's accepted. So let's submit. And the solution is working really great here. Let me explain you the solution once again. So I initialize my left and right pointers with 0 indices, 0 values, and then I give my first loop, which is r is less than length of nums, where I loop around the entire array. And what I am doing, I increment my right pointer every time it is within bounds, that is r plus 1 is less than length of nums, and nums of r is equal to nums of r plus 1, that is since a repetition happening. In that case, I increment my right pointer and I increment my count of repetitions. After that, I loop the second time, the nested loop, where I take the min of 2 and count. Count could be 1 or no, right? And based on that, the minimum of 2 and count, I get the value for how many times I have to do this swap. And then I do nums n is equal to nums of r. That way the replacement happens, and I increment my left pointer. Now for this outer loop, while r less than length of nums, I need to increment r until it reaches the nums length of nums. Sorry, I increment my r by 1 every time here. And then finally, what do I return? I return O, which is the index before which all sorted elements in non-descending order will be there in my array, repeated at max twice. So I hope the question as well as the solution is clear to you. If you have a better approach to solve the problem, share it in the comments with me. If you like my way of solving problems, subscribe to my channel to get your notifications for our daily code variants and the solution along with it. If you have any other doubts, any questions, mention them in the comments. I'll be happy to address it. Thank you.